Today on Aqua Kids.
Ocean acidification will have severe consequences for marine life and humankind. See what the students of the Marine Academy of Science and Technology in New Jersey are doing to study the problem and its effect on lobsters.
Aqua kids, doing what we have to do. Saving our earth, land, air, and sea. All we gotta do is keep it green and blue. For me and you. Aqua Kids.
Hi, I'm Hannah Jones here with Aqua Kids. Today we're visiting MAST, the Marine Academy of Science and Technology. We're also going to visit a NOAA laboratory.
NOAA? What's that?
It's the National Oceanic and Atmospheric Administration.
What do they do?
A whole lot of different things. So let's go find out what we're going to do today.
So Hannah said we're going to be learning about ocean acidification?
And lobsters?
What do those two things even have in common?
I have no idea. Let's go find out.
All right.
This should be interesting. Yeah. Hey Dan, how's it going?
Hello.
Hey. What is this? Does Einstein or Edison live here?
No, this is a creation of my own design. This is a tool we use to educate children on what ocean acidification is.
Ocean acidification? What's that?
I'm glad you asked. Ocean acidification is what this lab is all about. Here at the Sandy Hook Lab for NOAA National Marine Fisheries, this lab is dedicated to ocean acidification research. Now, ocean acidification has everything to do with carbon dioxide. Do you know what carbon dioxide is?
Yeah.
You do. Where does it come from?
Breathing?
Cars?
Exactly. It comes from breathing and the burning of fossil fuels. Big things are cars, factories, a lot of natural sources also. Fires, forest fires, volcanoes is a big producer of carbon dioxide. So what ocean acidification is all that carbon dioxide that goes into the atmosphere eventually goes into the water.
How does the ocean absorb the carbon dioxide?
Well, they want to be in equilibrium. So if there's more carbon dioxide in the atmosphere than the water, the carbon dioxide wants to transfer into the water. So in years of putting it into the atmosphere, there's a lower concentration in the water. It's always going to travel there. And eventually, how it used to work is organisms would take up the carbon into their bodies, they would die, it would fall to the ocean floor and be covered with more and more layers. But since now we're adding more and more, what's happening is the chemical reactions are a little offset. So the carbon dioxide is breaking into bicarbonate and carbonate. When those happen, you lose a hydrogen ion. And do you know what acidity means?
No.
No.
Okay, so for our purposes, acidity is the increase of hydrogen ions in the water. So things are either acid or basic on a scale of 0 to 14, 7 being neutral. So distilled tap water is around 7. Your body, I believe, is around 7.3, 7.4, your blood pH. The ocean historically was around 8.3, now it's about 8.1. This is a global average due to the absorption of CO2. Now, 8.1 to 8.3 doesn't sound like a big deal, but acidity, which is measured as pH units, is a logarithmic scale. Do you know what a logarithmic scale is?
Logger what scale?
A logarithmic scale, it's basically a compressed version of a large scale. So everything is broken into tens, factors of tens. So when I say that the pH since 1751 has dropped from 8.3 to 8.1, that really transfers to a 30% drop. Now, the rate at which it's dropping is really important because this has happened before. There was an event, they say 20 to 50 million years ago, where the pH decreased as fast as it is today due to a large greenhouse event. And that was followed by different changes in the ecology of extinctions.
Is it supposed to be a neutral pH or low, or like what's the correct amount it should be at?
What our ocean should be at and what it's been at for the past thousands of years is about 8.3.
Just above the
Just above. Neutral is considered 7. So the ocean is not neutral, but it's been working at 8.3. That's what organisms that have evolved to be what they are today have lived at for thousands of years.
Now it's time for Aqua Quiz with your host, Drew Cruz.
Looking good, huh? I'm your host, Drew Cruz, and now it's time to test your knowledge with Aqua Quiz. Ocean acidification is the ongoing decrease in the pH of the Earth's oceans caused by the uptake of carbon dioxide, or CO2, from the atmosphere. An estimated 30 to 40% of the carbon dioxide from human activity released into the atmosphere dissolves into oceans, rivers, and lakes. What are the two major sources of carbon dioxide in the atmosphere? Are they A, fossil fuel emissions, B, dairy farms, C, deforestation, or D, landfills? I'll have the bitter facts after the break. I'm back with the answer to today's Aqua Quiz. What are the two major sources of carbon dioxide in the atmosphere? The answer is A and C, fossil fuel emissions from coal, oil, and gas, and deforestation. I'll have another burning Aqua Quiz next week. Burning? Really? Oh, coal, oil, and gas. Not funny.
Welcome back to Aqua Kids.
So Dan the man, tell us about your machine.
Well, this is a device we created here in the lab to help educate children about ocean acidification. What it demonstrates is the sources and the potential changes to water. So what we have bubbling here is air. We explain to children that that's air and that this is bubbling in water, and we ask them, like I asked you guys, sources of CO2. They come up with all things they could think of. And then what we do is we have them all pick a switch. You guys want to pick a switch?
Okay. Yeah.
All right, you got the bike, you're the car, and I'll be the factory.
Okay.
All right, so we tell the children to flip the switch. As soon as they flip the switch, to watch the numbers. This number here is indicating the pH of the water. All right, so everybody flip their switch. I just turned a factory on, you just turned a car on, and you're over there pedaling your bike. All right. Okay, so now as soon as you see your numbers start to drop, that means you're adding a lot of CO2 to your water and you want to shut it off. So the factory, the numbers are just starting to drop. I'm going to shut mine off. Now we also included an indicator dye in here.
Turn it off? Sorry.
Is it dropping?
Yeah.
Yeah, shut it off. That indicates when the pH is actually changing. So now we're waiting for the boy on the bike. Now he's breathing really hard, producing a lot of CO2, right? All right,
It's not changing.
it's not changing. Do you think that boy, if he pedaled his entire life, would produce enough CO2 to put enough into the atmosphere to ever change the ocean?
His entire life?
His entire life.
No, I
No,
don't think
you can
so.
flip that off. He is never going to change. So now, what this is showing is the different sources. Do you know what you can do to lessen the impacts of these sources of CO2?
Well, you can obviously switch the switch at home, turn the
That's-
lights off.
Exactly. By turning your lights off when you're not using them, you decrease the amount you're taking from this power plant, which is burning fossil fuels. What else?
I guess you could bike to school or
Or
work.
walk,
Bike or walk, so don't take the car.
carpool.
Carpool. There's
a smart
some other
idea.
big ones. I know, have you ever heard of buying local? A big producer of CO2 is the transportation industry. So the trucks that bring the products that you're buying at your local store, if they're brought from far away, they're producing a lot of CO2. If you buy, say, vegetables produced locally, they've only traveled a short distance. So if you bought something that was made way in another country, it had to get loaded on a truck, loaded on a ship, driven across the ocean, loaded back on a truck or train, brought to your local store. So it produces a lot more CO2.
Yeah.
The shipping industry and airplane industry are some of the highest producers of CO2.
So what can we do to make a difference?
Unfortunately, the only thing that can be done is reducing the amount of CO2 we put in the atmosphere. It is estimated that we have already put enough CO2 in the atmosphere that if we flatlined all production of CO2 right now, it would take upwards of 10,000 years for the ocean just to deal with what we've already put in the atmosphere.
10,000 years?
Yes, possibly 10,000 years or more.
Thanks, Dan. That was awesome.
Thank you for coming.
Great invention.
Oh
you.
yeah.
Aqua Kids will be right back. Welcome back to Aqua Kids.
So what's this over here? What's all the tubes and the water and the tubs?
This is our most current experiment in ocean acidification. Right now we are working with juvenile lobsters. We took lobsters about a year ago that were about 2 to 3 centimeters long. So they were about this big. We put them into our system in all these troughs here, and we gave them each a pH. So our high pH was 8.1, our middle pH was about 7.8, and our low pH was about 7.6, 7.5. And they've spent the year at that pH growing and just living in it. And what we're doing here is a preference trial.
Preference trial? Preference trial, what's that?
That's when the subject you're studying gets to pick between two options. So the options we are giving them is a high pH and a low pH. And they start in a bucket that is a mix of the two. They basically walk down a hall, come to an intersection where one direction has one pH, another direction has a different one. Our high pH that we're using is 8.1 and our low pH is 7.5. We put the lobster in this bucket here, we dim the lights, and we give them about 2 hours to walk around, make their decision. We come back and we peek in and see where they're located. And that tells us what they prefer.
Well, show me how this experiment works.
Okay, so you gotta sneak in here and very quietly open up your bucket and see if there's a lobster in there.
There is. Huh.
So that means in the time he was in this experiment, he chose to find shelter in this pH, which happens to be the low pH of 7.5. Now that doesn't represent all the lobsters, that's just one individual in the experiment.
So why does he choose that? How does he know what to
We
go
don't
in?
exactly know yet. They can sense the water chemistry through chemosensis and just their probably overall how they feel, how they're breathing. But we're not sure in this experiment. So what we're going to do is we're going to run each individual multiple times to replicate. And what we do is we add it all up and see if there's any kind of trends, like if they prefer this more than this.
Lobsters, pH, choosing a bucket? Do we really care? Why does it even matter?
That's another good question. So we do more than just the bucket preference. This trial will tell us, if they would prefer to live in a different place, but they spent the year growing, so we measure the differences in growth based on pH treatment, which we find some trends there. We also set up cameras and measure their activity overnight. And this is where we get into more of a behavioral aspect. So if a lobster is behaving different at this life stage, which is very crucial, he could be eaten, and then we'll have less lobsters. So if he doesn't realize that he's acting careless and a predator gets him, that could be a trend that we're seeing throughout all lobsters in these pHs. Whereas if their natural behavior is they hide, they're more careful, the population can survive.
So, why is he blue? Did you paint him, or do you like the color?
We did not paint them, but this is a great question. So the difference between these lobsters and the lobsters you see in the supermarket are these are aquaculture lobsters. They are all blue because they came from an aquaculture school who got their genetic stock from the New England Aquarium. They did a study on why this happens to lobsters. This is a naturally occurring, rather rare genetic mutation. So lobsters normally have 3 pigments, red, white, and blue. These ones are all because of a genetic mutation missing red pigment. These came from the Bridgeport Aquaculture School in Connecticut.
So, after you get all your results and find the right pH, what's your guys' next move?
So with any of our experiments, which all have to do with economically important species, we take our results, we publish them, and we get it in the hand of policymakers, congressmen, those kind of people, who then can make management decisions for fish stock and how things are fished for.
Cool.
Oh, hi. I'm so glad you're here. It always excites me to meet young people who love to protect the earth as much as I do. Young people who are pioneering powerful ways to conserve and protect our planet for all of us. I call them eco-defenders. Let's find out what they're up to.
I'm Asa Needle, and I work with the Toxic Soil Busters in Worcester, Massachusetts. Worcester is a small post-industrial city that's been passed over by a lot of economic currents. When there was a new wave of immigrant labor in the industrial boom, there was a whole bunch of cheap housing set up, and that housing was painted with lead paint. Lead paint is cheaper and it's built to last, and that's why it was used for almost a century. And now, even when it was outlawed in the 1970s, we have to live with the consequences of this long-lasting poisonous paint. Lead is toxic to everybody, but it's especially horrific to children. It attacks their internal organs and stunts their growth. It can attack their bones as well as their brain. You cannot even know that you have lead paint in your soil. It's all over the city, in the nice neighborhoods as well as in the poor neighborhoods. Toxic Soil Busters started when a group of youth and adults came together around the issue of lead soil in Worcester. We try to spread the word as wide as possible that you can give us a call and we'll just show up anywhere in Worcester and we'll do the lead soil test free of charge. I think we should test this soil separate from this soil because of the separate drip lines here and here.
Yeah, it completely makes sense. Yeah, totally.
And after we send that to a lab and it comes back, we put it in a spreadsheet. After that, we call them back with the test results and set up a SketchUp where we send a proposal of what we want to do in the house. We can ask if they're interested in doing remediation, such as bringing in a new layer of soil with a layer of landscaping fabric. Often, if you can't get the lead out of the soil, you have to simply put a Band-Aid over it to reduce the accessibility it has to humans. In the case of this particular homeowner, there was a patch of lead soil that she wanted covered up, so we laid down landscaping fabric and covered it with pea stone, as well as a sandbox for her child to play in back. Elsewhere, she wanted to grow plants and vegetables, so we built her a couple of raised beds in the front where she could do that and maybe bring her child out there and do that as well. With Toxic Soil Busters, we remediated over 40 yards, helping dozens of children avoid lead soil toxics, as well as outreach to hundreds, maybe thousands of people all over Worcester. You don't know where that's going to go. You say these things, you throw out these stones, and then you don't know where the ripples go. But you hope that there's a chain reaction, that that act of education or that act of making a greater awareness somehow creates a greater world one by one, piece by piece.
Wasn't that amazing? Okay, now it's your turn. If you or someone you know is doing something remarkable to help our planet, let us know about it, and you could be our next eco-defender. I gotta go.
Hi, Drew here. Join the Aqua Kids next week as we go seining in Sandy Hook Bay, New Jersey, and study the diverse marine life in the area.
I'm Jalen, and this is Earth Edition. In the last 100 years, marine life has been suffering from the effects of ocean acidification, which is a result of carbon pollution caused by the so-called progress of mankind. The carbon dioxide in the atmosphere interacts with the Earth's surface water and alters the delicate pH balance of the water. Ocean acidification is a particular concern to the Maine lobster industry. Lobsters now develop slower, and baby lobster populations off the coast of Maine are decreasing, possibly because of the warmer, more acidic waters. Maine state government is recommending more research on ocean acidification and its impact on Maine's seafood industry. Solutions will include ways to reduce carbon dioxide emissions with plans to limit runoff from potential sources of acidity, such as farms and overdevelopment. This is a global environmental issue that has far-reaching ramifications on the seafood industry, the ecosystem, and all of mankind. I'm Jalen, and this is Earth Edition.
Welcome back to Aqua Kids.
We're here now with two students from MAST.
The Marine Academy of Science and Technology.
So how did you guys become a part of this? How'd you end up in the NOAA lab?
Well, MAST is a 4-year career academy that focuses on marine sciences and technology. And part of that is that senior year, we get to work with a mentor. And we work on a senior project that works in either a science field or a marine technology field. And for our senior project, we got to work with Mr. Resort here at the NOAA lab and work on the state-of-the-art ocean acidification lab that not even the best scientists in the world can sometimes work on.
Well, that is really awesome.
It's really awesome.
So what are you guys doing right now?
Right now, we are feeding the lobsters.
How much do you give them?
We give them about 8 pellets, so about 1 pinch, and for the larger ones, about 16, so 2 pinches.
What's interesting, though, is the fact that how much food we give them actually is dependent on the temperature of the water they're in. The higher temperature increases their metabolic rate, which means we have to feed them more.
Oh, well, that's really cool. Well, what do they eat in the wild?
Well, in the wild, they'll typically eat clams, small crustaceans, or worms.
And then what do they get eaten by?
Well, once they're fully grown, they really don't have any predators that eat them. But right now, when they're about 1 or 2 years old, they have to look out for cod, which might attack and eat them.
So why are they in individual buckets?
Well, because the lobsters are cannibalistic, so if we put them in the same buckets, they would attack each other.
They would?
Yeah, they try to eat each other.
Well, that's scary.
After getting to spend the day with the Aqua Kids and see what their mission is really all about, it's that everybody can make a change and make the world a better place.
Okay, now I understand.
Right? It makes sense how ocean acidification and lobsters relate to each other.
Before we leave, let's find out what the kids learned at the lab.
Hey! Today was really interesting. We learned about ocean acidification,
By conserving energy,
turning off lights,
carpooling or riding your bike,
buying locally.
and we even learned how lobsters react to a change in pH.
Oh my goodness, that's a lot to learn in one day, but all great tips on how we can help our planet. Remember, it's up to you to keep it green and blue. Help protect our planet, and we'll see you next time on Aqua Kids.
Bye!
Aqua Kids, doing what we have to do. Saving our earth, land, air, and sea. All we gotta do is keep it green and blue.